Hi everyone, welcome to the Hadoop demo class. Today we'll be talking about introduction to Hadoop, or you can say introduction to big data. So let's start with my introduction. My name is Neeraj and I'm having total 16 years of experience in IT industry. If I talk about my last 6 years of experience, starting from January 2011 till today, I'm working on big data technologies. Or in more detail, you can say I'm working on Hadoop, HBase, Hive, Pig, Scoop, Flume, Uzi, Spark, Scala, etc. Along with working on these technologies, I share my knowledge with working professionals like you so that you can also learn this new and emerging technology. You can also jump into a big data world. So that was a quick introduction about me. Now let's start with introduction to Hadoop. So we'll be starting the class with the agenda. So the agenda for the demo class is Internet in real time. What is Hadoop? Master slave architecture. Hadoop distributed file system, which is also known as HDFS. MapReduce. Hadoop services. What is big data? Why Hadoop is important for career. Prerequisites to learn Hadoop and Hadoop training details. This is the agenda and we'll be covering this in much more detail one by one. So let's start with the first one, Internet in real time. You know that we are using internet throughout the day. Starting from early morning till late night, we are using internet. We are searching for something on Google. We are watching videos on YouTube. We are purchasing household items and other items from e-commerce websites. eBay, Amazon, Flipkart, Snapdeal. We are doing online transactions. We are part of Facebook, LinkedIn, Twitter, and we are sending messages on WhatsApp. So ultimately, starting from early morning till late night, whatever activities you do over internet, that is ultimately increasing the data. And how fast the data is being generated, this slide will give you the brief idea. You can see at the top of this, at the bottom of this screenshot, it is saying that by the way, in the 5 seconds, you have been on this page, approximately 1,12,870 GB of data was transferred over the internet. Isn't that surprising? Just 5 seconds and approximately 1,12,870 GB of data was transferred over the internet. If you want more detail, you can have a look. Start from left upper corner, Twitter. In this 5 seconds, 55 new accounts are created and 28,500 new tweets are there. YouTube, 11,570 video hours are watched. At the same time, 10 video hours are uploaded. You can see the stats for LinkedIn, 901 user searches, Skype, these many calls are placed using Skype. We have the stats for Instagram, how many likes, how many comments and how many snaps uploaded. We have the stats for Google, how many searches and how much of ad revenue generated. Amazon, how many items purchased and how much money spent. App Store, how many applications are downloaded, and Play Store, how many applications were downloaded from Play Store. You can see the stats for Facebook. These many likes, these many posts and approximately 30 GB of data. WhatsApp, 60 new accounts are created and millions of messages are sent. Ultimately, you can say that gone are the days when we were dealing in MB or GB of data. Nowadays, we are dealing in terabytes and petabytes of data. And in very near future, we may have to deal with gigabytes of data, because data is increasing tremendously day by day. And in order to deal with this type of data, this much of data, our traditional approach is not sufficient. That's why we have a new technology in the market, that is Hadoop, which will help you to deal with this large amount of data. So let's move to the next slide. The next is, what is Hadoop? So first of all, Hadoop is an Apache product. Apache is the company which is developing this software Hadoop, and this is still under development. Every few months, every few weeks, Apache is releasing newer version of Hadoop. And this is an open source framework. As we all are from IT background, we very well understand what's the meaning of open source. That means you can go to Apache website, you can download this software and you can use it for your personal use or maybe for your enterprise purpose. And there is no cost associated with that. That is free of cost available on Apache website. Hadoop is providing distributed storage and distributed processing. Although we can explore it technically, but let's start with a layman language example. Our main target is that we should be clear on the basic concept of Hadoop. Later on, we can explore each and everything in much more detail. Suppose there is a school, and in that school there is a principal, and there are 10 teachers as well. Now suppose there is a task of checking 1,000 answer sheets. If principal himself or herself will try to check those 1,000 answer sheet, more time will be taken, because checking 1,000 answer sheet is not a small task. On the other hand, if principal can distribute the task among 10 teachers, the same task can be completed in less amount of time. And there is nothing like rocket science in that. It's very old mathematical concept. More number of workers will be taking lesser time to complete the job, and less number of workers will be taking much more time to complete the job. The same funda is applicable to Hadoop. Hadoop does not concentrate on overloading a single system. Instead, it is dependent upon multiple systems. That means if you have a large amount of data, Hadoop can distributively store it on multiple machines. And similarly, Hadoop can distributively process it on multiple machines. So Hadoop is providing you distributed storage and a distributed processing environment. We are not overloading a single system neither for storage nor for processing. Multiple machines will be participating in this, which will help us to deal with a large amount of data in less amount of time. So with the help of this distributed nature, we can deal with large amount of data very easily. Now let's move to the next slide and we'll throw some more light on the Hadoop architecture. So Hadoop is providing a master-slave architecture. You can compare with school example. In school, principal was there who was controlling the teachers, or I would say who was assigning the task to the teachers. There was a big task. Hadoop was splitting that task into multiple smaller parts and distributing among multiple teachers. Similarly, in Hadoop, we have a concept of master and slave machines, as you can see. As a user, we always interact with master machine. We cannot interact with slave machines directly. Suppose you have large amount of data, some 2 terabyte of file, and you want to store it. You will simply request the master machine that I have this much of data and I want to store it distributively on multiple machines. That's all. After that, it's master machine's duty to split your data, split your big file into multiple smaller parts and store it distributively on multiple slave machines. Similarly, in case you want to process your data, in case you want to analyze your data, you want to apply some logic on your data, you will request the master machine that this is the logic, this is the job which I want to execute, and after that it's master machine's duty to distribute the task among multiple slave machines. You can notice that there is one more system, secondary master, because in case master is down, there must be some backup. Just like if I compare with school example, if principal is absent, we have vice principal who can look into the activities, who can look into the responsibilities in case principal is absent. Similarly, if master machine is down, secondary master can look into the responsibilities. And this complete setup, master plus secondary master plus multiple slaves, this complete group of system is known as Hadoop cluster. So friends, in case you are having any doubt till this slide, you can ask me. Otherwise, we can move to the next slide. So friends, let's move to the next slide. The next slide is Hadoop distributed file system. In short, you can call it as HDFS. In one of the previous slide, we were talking about that there are two main modules of Hadoop: distributed storage and distributed processing. This slide is more about distributed storage. Let's have a look at this picture. You can see that we have a box which says name node. Till previous slide, I was using very layman terminology like master machine, slave machine. But now in Hadoop terminology, master machine is known as name node. So the box which says name node is nothing but my master machine. We have a backup node, that's nothing but my secondary master. Or you can say backup for the master. Apart from these two, if you will come down, I have 5 data nodes. Those are nothing but my slave machines. And this dotted arrow indicates that name node is giving the required instruction to all the data nodes. Or you can say my master machine is controlling all the slave machines. If you will look at these colorful blocks on the left side, these colorful blocks are nothing but part of a big file. The file is too big to be stored on a single system. So what Hadoop has done, Hadoop has splitted this file into multiple smaller parts. In this case, this file has been splitted into 15 smaller parts. And now these 15 parts can be easily stored on multiple machines. Every machine can participate in storage. And when I say every machine, I am talking about slave machine. Master machine and backup master machine are neither participating in storage nor they are participating in any processing. So what exactly they are doing? They are mainly for coordination, controlling, managing. They are giving the required instruction to the slave machines. So you can notice that all the blocks, all the smaller part of a big file are now stored on multiple slave machines. Every slave machine has a hard disk, its local storage, and on local storage the small parts of the file are stored. So this was all about storage part of Hadoop. Let's move to the processing part of Hadoop. So the technical name for processing part of Hadoop is MapReduce. So MapReduce plays very important role, very key role in Hadoop framework. And why it's playing a key role? Why the storage part was not playing the key role? In previous slide we talked about Hadoop distributed file system, the storage part of Hadoop. Nowadays storage is not a big deal. You can attach extra hard disk to your system. You can even use portable hard disk, or you can use some cloud storage solution system like Google Drive, Dropbox, or Amazon Web Services. There are many cloud storage solution available which you can use for storing your data. So processing the large amount of data over a single system is quite difficult, and that is very important because that would give you the required stats. For example, you are logging into Facebook and Facebook is displaying different type of advertisements that can be related to a new year party, that can be related to online training, that can be related to some smartphone. And nowadays you must have noticed that suppose you are going to Amazon website and you are searching for a smartphone. You browsed for the phone, you compared few phones, and then you came back. You did not purchase anything from Amazon. Now when you are logging into Facebook, you will be surprised that now Facebook is displaying the advertisement for the same smartphone from Amazon. How is it possible? Is there any magic? The magic is all about analytics. Whatever activity you perform over internet on different websites, those are used to display the advertisement for you. Nowadays suppose you are looking for some flights but you did not book it. The next day onwards, on every website you go, you will find the similar advertisement for the flights. So this is all about analytics. When you have large amount of data, when you have a click history detail available, by utilizing that, you can enhance your business. You can make your advertisement more effective. When you click on any advertisement on Facebook, your details are captured. Like what's your username, which country you are logged in from, what is the date and time, which type of advertisement you are clicking upon. Because later on the data can be utilized, can be analyzed. Like people from which age group, people from which professional background, people with which gender, people from which geographical location are interested in which type of advertisement, which type of activities. That will help Facebook to make their advertisement even more effective. So ultimately storage of data is not a big deal, but processing of data, generating of useful stats, analyzing the data is more important. That's why MapReduce plays a key role in Hadoop framework. So MapReduce is a programming model for writing application that rapidly process large amount of data. MapReduce has a special feature that it can execute the logic on multiple machines parallelly. As a user, you are providing a logic to master machine that I want to execute this job. After that, master machine has the capability that it can execute the same logic on multiple machines parallelly. Ultimately, the large amount of data which is stored on multiple machines can be processed easily, can be processed in less amount of time. So MapReduce is consist of two words, map and reduce, or you can call it as mapper and reducer. In order to understand mapper and reducer in much more detail, I will take you back to the school example. So let me remind you, the principal had distributed the task among 10 teachers. That means every teacher is responsible for checking 100 answer sheets. First teacher will check 100 answer sheet and will be preparing the result for those 100 students only. Similarly, second teacher will be picking up the next 100 answer sheets and will be preparing the result accordingly. Ultimately, all 10 teachers are independently checking 100 answer sheet each and will be preparing the result accordingly. At the end, there are 10 small results. Principal may come and may say that I have distributed the task among all of you, that's fine, but that does not mean that you will give me 10 different small results. I don't need that. I still need one consolidated result for my school. So what can be done now? Principal can choose one teacher that can you please collect the small results from each teacher and consolidate that into a single consolidated result. That's what I need. So the individual processing every teacher was doing independently, that independent processing is known as mapper. And the last activity, one teacher was collecting the small result from each teacher and combining that into a single output, single result, and handing over it to the principal. That activity is known as reducer. So this school example was given just to make it simple for understanding. Let's come back to Hadoop. As a user, you submitted a job to master machine, and master machine will distribute the job among multiple slave machines. Now every slave machine is processing your data independently without bothering about other slave machines. That independent processing happening on every slave system is known as mapper. And later on, master machine will choose one slave that you have to do the consolidation part. That particular slave will collect the small output from all the slave and then combining it to produce the final output. And this combining activity, this consolidation activity is known as reducer. If you want some definition type thing, it's there on the slide. Mapper processes input data parallelly on multiple machines to generate intermediate output data. What mappers are producing is not the final output, it's intermediate output, right? And then reducer will be fetching intermediate output from all the mapper and generate final output data. That is all about reducer. So friends, this is all about the processing part of Hadoop, or you can say that MapReduce part of Hadoop. In case you are having any doubt till this slide, you can ask me.
Produce only in the master?
No, master is not participating in storage, neither it's
Okay.
participating in the processing. So when we say MapReduce, both are taken by your slave machines only. Just like if I compare with school example, principal was not checking the answer sheet. Initially, all 10 teachers are checking the answer sheet, 100 answer sheet each teacher. That independent processing is known as mapper. And later on, one teacher will be collecting that small result from all the teachers and consolidating that into a single result. So whether it's mapper or it's reducer, it is taken care by slave machine, but controlled by master. Master will decide which machine has to do the reducer part, which machine has to do the consolidation part, and accordingly that particular slave system will be doing the consolidation part.
Okay. Thank you.
Is it clear now?
Yes. Thank you.
That's good. Okay, so friends, let's move to the next slide. The next we have is Hadoop services. When we install Hadoop on our system, we will be starting with the regular classes tomorrow, and the very first thing we will do is installing Hadoop on your system, so that whatever things I will show, I will demonstrate practically on my system, you should be able to do all these things practically on your system as well. So once the Hadoop will be installed, few services will be running. and let's talk about those services. The first two services are name node and data node. Few slides back, I was saying that name node is nothing but my master machine and data node is nothing but my slave machine, right? But suddenly I am saying that these two are services. So which one is true? Actually, these are services only. But since the name node service is running on master machine, that's why even master machine is known as name node. And similarly, data node service is running on every slave machine. That's why every slave machine is known as data nodes. Otherwise, these are services. And these two services are taking care of storage part of Hadoop. Hadoop Distributed File System, HDFS. Similarly, we have two more services which are taking care of processing part of Hadoop, or you can say MapReduce part of Hadoop. One is job tracker, which is running on master machine, and another one is task tracker, which runs on every slave machine. So you can say that these services running on master and slave machine are taking care of your storage and processing part. So name node along with all the data node services are taking care of storage part of Hadoop. And similarly, job tracker service along with all the task tracker services is taking care of processing part of Hadoop. As being a master, name node will accept your storage related request. You want to load some data into multiple system, distributed storage. So name node will accept your request and then assign the task to multiple data nodes so that they can split the data into multiple smaller parts and store it on distributed system. Similarly, when you want to execute some job tracker will be accepting your request and will be distributing the task among multiple slave machines. Along with the master, we have a secondary name node which is useful in case of name node failure. So these are the different services running on master machine, secondary master machine, and multiple slave machines. So in case you are having any doubt on any of the service, you can ask me. Yes, Karthik, go ahead.
Hello? Yeah. The secondary name node is a master machine, right?
Secondary name node is not master machine.
Hello?
That's the backup for master machine.
Okay. Okay. So, in the present slide, where is the master machine, the name node?
Yes, this is the master machine on which name node service and job tracker service is running. One service is taking care of this part and this job tracker service is taking care of processing part.
Okay. So I have a question that, the same thing. So the same master machine will take care of the storage and the processing, right?
Right.
Okay. So when it is divided to the slaves, the same thing. So what does the data node do and what does the task tracker do?
Okay. So name node, as we discussed earlier, master machine does not participate in the storage. Name node is for accepting your request. If you are storing some data, name node will accept your request and then it will distribute the task among multiple data nodes. So actually your task will be by data nodes. Name node is just for controlling and managing the things. Similarly, when submitting a job tracker will accept your job. It's not running by itself. It is accepting your job and then distributing it among multiple task tracker. So just like he was assigning the task, he was distributing the task, but he was not checking the answer sheet by himself. Answer sheets are actually checked by your teachers only.
Okay. And also, when you said in the last example, the teachers take all the 100 answer sheets, right?
Okay.
So when we compare with this data, so each slave machine will pick the data randomly, or like is it distributed among, like will it take only the distributed data, or again will it take the data which is done by other slave machine?
No, first of all, one slave machine is not bothered about any other slave.
Okay.
When you store your data will be separated into multiple smaller parts and stored on multiple systems.
Okay.
That means data is already shared on multiple machines. When you talk about processing, then there is no role of storage. It's already there on every system, right? So when you talk about processing, it will start executing. I mean, master machine will distribute the task among multiple slave machine, and multiple slave machine will be parallelly processing your data. Initially, mapper will be happening. That means every machine will be independently processing your data. And later on, one machine will consolidate your output. That is known as reducer.
Yeah. Hello.
Is it clear now?
Yes, sir. And it is the master machine duty that the data is perfectly distributed to each slave, right?
Absolutely.
Okay. Yeah. Thank you, sir.
Okay.
You can go ahead.
Okay, so friends, this was all about the different services running on different system of Hadoop cluster. Let's move to the next slide. The next slide is what is big data and what is the difference between Hadoop and big data. Because Hadoop and big data are the two things which are used interchangeably. Someone may say that I'm working on Hadoop, and the next day he will say that I'm working on big data. Are these two things same, or the two things are related? So let's try to understand what big data is. So big data is story of 3 V's. And what are those 3 V's? Those 3 V's are volume, velocity, and variety. Volume of data we have seen on very first slide, right? 1 lakh, few thousand, few hundred GB of data was transferred over the internet. So volume is very high. And velocity, the speed of data. That 1 lakh, few thousand, few hundred GB of data was generated just in 5 seconds. That means even the velocity of data is quite high. And variety. We have audio files on internet, we have video files, we have status messages, we have, you can say, advertisement, we have YouTube, we have Facebook, LinkedIn, Twitter, e-commerce website. There are so many things. So variety of data is again very high. And if I combine these 3 V's, that is volume, velocity, and variety, you will find that the data complexity will be very, very high. And in order to deal with that complex data, Hadoop is not sufficient. Because Hadoop is a base technology. It provides the base for other sub-technologies. On top of Hadoop, other sub-technologies like HBase, Hive, Pig, Scoop, Spark, Scala. So these type of sub-technologies are running on top of Hadoop. So when we say Hadoop, that means only Hadoop. And when we say big data, that means Hadoop plus its sub-technologies. So either I can say I'm working on Hadoop, HBase, Hive, Pig, Scoop, etc. To make it more simple, I can simply say I'm working on big data technologies. So big data is something bigger than Hadoop because big data contains Hadoop plus all other sub-technologies as well. So that's the difference between Hadoop and big data. So now let's move to the next slide. The next slide is why Hadoop is important for career. People from different background, data warehouse housing background, Java background, .NET background, Informatica, and even from non-technical background, like medical background. The people from medical background or any other non-technical background, what they are doing in Hadoop is they are analyzing some data. There was a medical guy in my previous batch. What they were doing is their company was distributing some medicine across different countries in the globe, and they have done some survey. What is the after effects of that medicine? What are the positive things? What are the side effects? All that stuff, depending upon different age, different climate, different food habits. Ultimately, they had some large amount of data, and they wanted to analyze the data, because that analysis will help them to move their business in the right direction. So anyone who is having large amount of data in any form, they can work on Hadoop. So let's talk about why Hadoop is important for career, why people are running towards this new and red hot topic. The very first point is better salary. If you will compare the billing rate of a Hadoop consultant with any other technology consultant, you will find it on little higher side. Second thing is big companies are hiring. When a new technology is coming in the market, there are many things which comes in our mind, whether we should learn this technology or not. I will learn this technology, but tomorrow if I join some other company, whether they will use this technology or not, whether there is a scope for this technology in future or not, whether there is a bright future of this technology or not. There are many questions coming in our mind. But all these questions don't make any sense for Hadoop. The reason being is very big companies are involved in that. Let me talk about Yahoo. Yahoo had set up a Hadoop cluster of 4,000 machines. And what they are doing, they are scanning the Yahoo mails to find out which one is genuine mail and which one is a spam mail. Ultimately, they have some data and they are analyzing it. Similarly, Facebook. Facebook is extensively using Hadoop and Hive to analyze the click history. People are doing different type of activities on Facebook. People are clicking on different type of advertisement on Facebook. All that data is captured in the log files, and later on, with the help of Hadoop and Hive, Facebook is doing business intelligence. It is making its advertisement more powerful, more effective, more relevant with the help of this analysis. So very big companies are hiring. That means it's not like that today Hadoop is in use and tomorrow Hadoop will disappear. It's not like that. There is quite bright future of this technology. It's globally available. If I talk about e-commerce website, if I talk about WhatsApp, Facebook, LinkedIn, Twitter, Google, YouTube, online banks, these things are available across the globe. Hence, the opportunity for Hadoop are also globally available. So ultimately, if you are learning this new technology, that means better job opportunities are waiting for you. So these are some points why Hadoop is important for the career. In case you are having any doubt on any of the point, or maybe if you want to add something here, you can do that. So the next slide is all about prerequisites to learn Hadoop. So we are technically done with introduction to Hadoop. To conclude in a single line, I would say Hadoop is a distributed storage and distributed processing environment which will help you to deal with large amount of data, to store them distributively on multiple machines, and to process them distributively on multiple machines in less amount of time. Now in case we are planning to go for this training program, what are the things we need? Hardware wise, software wise, knowledge wise, let's check these things out. The very first prerequisite is Linux based operating system. You may be attending this demo from Windows, but let me tell you, Windows is not the operating system for Hadoop. We need a Linux based operating system. That can be Mac OS, that can be CentOS, that can be Red Hat, that can be Ubuntu. I have highlighted Ubuntu in a different color because in case you don't have any of these operating system, nothing to worry about. We can go ahead with Ubuntu. First of all, Ubuntu is an open source. It's free of cost available. Second thing is we can install Ubuntu in a virtual box. That means your Windows will be as it is. We will not touch your Windows. You can still do your personal things on Windows. On top of Windows, we'll be installing VirtualBox, and inside VirtualBox, we will be installing Ubuntu. Inside Ubuntu, we'll install Hadoop, and we will be able to do all the things practically on our system. So tomorrow, when we will be starting with the regular class, the first half will be dedicated for Ubuntu installation. That's hardly 15-20 minutes one-time activity. That's all. So that is the most important prerequisite. That's completely in our reach and we can do that. The next is Java 7 or higher version is required. Do we need Java knowledge here? No. We are not talking about Java knowledge. We are talking about Java software. Java is free of cost available, and installing Java on our system is hardly 5 minutes one-time activity. We can even do that. Disk space is required to hold the large amount of data, and RAM is required to process large amount of data. And the interesting part is that there is no minimum specification from Hadoop. That means whatever PC, whatever laptop you have with any configuration, with any hard disk, with any RAM, that's good for Hadoop. If you have 100 GB of storage and you have 2 GB of RAM, that's fine. We can use that system as a Hadoop machine. A group of computers. In our previous slides, we had a picture in which we were talking about that there is a master, there is a secondary master, and there are 5 slave machines. So do we need these 7 systems for learning Hadoop? No, that's not required. Logically, your own system can work as a master as well as slave machine. Just like you can send an email from your email address to your email address, and you will definitely receive it. Because you are the sender, you are the receiver. And for the network, it does not make any difference whether you are sending an email from your ID to your ID or from your ID to your friend's email ID. It does not make any difference. Network has to follow the same process. Similarly, we can install Hadoop on our single system. Our single system can behave as a master as well as slave machine. So you can say that all the master services and all the slave services will be running on our single system. So these are the prerequisites for learning Hadoop. If anyone is having any doubt on any of the prerequisites, you can ask me. So let's move to the next and the last slide for today. That is Hadoop training details. So let's talk about the first type of training, that is Hadoop developer training. This type of training needs prior Java knowledge. It is suitable for the guys who are coming from Java background. Second and the more famous training is Hadoop Admin. The best part is it does not need Java knowledge. And it is suitable for guys who are coming from database, data warehousing, informatica, mainframe, business intelligence, or QA background. That means anyone who is dealing with data in any manner can go with Hadoop admin profile.
Excuse me, for the Hadoop developer, do I just need basic Java knowledge, or do I need, advanced Java knowledge?
No, advanced knowledge is not required. If you have very brief idea, very basic idea about core Java, that is more than sufficient.
Okay, thank you.
Yeah. So now let's talk about which type of training I will be conducting. We'll be conducting a combined training program, Hadoop admin plus Hadoop developer plus HBase plus Hive plus Pig plus Scoop plus Spark plus Scala and a POC, proof of concept. These things, HBase, Hive, Pig, Scoop, Spark, Scala, POC, these are common for Hadoop admin or Hadoop developer. You can say that 80% of training, 80% of 1 month training is common for admin or developer. Only few classes make small difference. I will be conducting 3-4 classes which are specifically for Hadoop Admin, and I will be conducting 2 classes which are specifically for Hadoop Developer. In case someone needs more development, since not everyone from our batch is not from the Java background, but suppose someone is from Java background and he or she says that I want some more development, I can even provide that separately. We may not be covering more developer stuff during the classes during the batch timing, because everyone is not from Java background, but separately on a separate timing, maybe over the weekend, I can conduct some extra developer classes if required, if someone is interested in that. Otherwise, Hadoop Admin plus all this sub technology does not need any Java knowledge. Only Hadoop developer would need Java knowledge. And if someone is interested to go for that, because nowadays companies are looking for one-man army, companies are looking for someone who can work as a Hadoop admin as well as Hadoop developer. In that case, you should keep yourself open for learning any new technology as well. What I can do is, I have some Java recordings available with me. Those are my recordings only. For someone, I conducted those Java classes on demand. What I can do, I can share those recordings with all of you. And by the time we will conduct the developer classes, usually we conduct developer class in 3rd week. That means you have 2 weeks time. In those 2 weeks, in your free time, you can go through those Java recordings, which will make you comfortable, which will make you aware about little Java knowledge. And once I will be conducting Hadoop developer classes, you will understand something. You won't be completely blank. So this is our training program, and some more non-technical details are displayed here. Training duration, that is 1 month, 5 days a week. And those 5 days are Monday to Friday morning India time, Sunday to Thursday evening US time. You can make a note of this because this is a little confusing. People from US usually they forget to attend the class on Sunday. So I'm repeating it again. Monday to Friday morning, that's India time. The same is Sunday to Thursday evening US time, so that your Friday night and Saturday night is free. So friends, that is all about Hadoop training details. And with this slide, we are done with introduction to Hadoop. Thank you.